Time for a little friedal crafts. Let's do the little alkylation this time. Friedal crafts alkylation. This is the one-stepper. Okay, there's the friedal crafts acylation, which is a two-stepper. Let's look at the, we're looking at the alkylation. Okay, this is the alkylation. As you notice, this is one step. Okay, these reagents run together in one step. This is all one step. You have this chlorinated thing, and you have AlCl3. This is one step. Contrasted with the acylation, which I'm not showing that mech now, but I will later. The acylation would be something like this. Step 1. I'm just drawing this because, you know, that's what you're going to see on the exam. You're going to see like an arrow. It doesn't matter like if it's like where the arrow is in like the line of like 1, 2, 3, 4, 5. It does not matter. It's just the arrow. And now this is the acylation. So alkylation means putting an alkyl group on there, which is, you know, C's and H's and all that. However, acylation means putting an acyl group on the benzene ring, which basically the way I think of it is like it's putting a ketone on there. And the acylation is different from the alkylation because the acylation runs in two steps. Step 1 is this chlorinated thing in the AlCl3. Step 2 is the water or HCO+, and this is needed. This is completely necessary and required in order to do the friedal crafts acylation. The alkylation, on the other hand, is just one step. You could have drawn this like this instead of this on the bottom. It does not matter. The important thing is that this is one stepper with no water, and this is a two stepper with water or HCO+ afterwards. So let's get into the acylation mech, or excuse me, alkylation. This one's actually a lot of fun because the problem with the acylation is that it's got a lot of issues at the end with the water, which I don't really think is very fun. But this is fun. Let's talk about it. So first step, obviously, we need to form our electrophile. So let's figure out how the heck are we going to do that. Well, first of all, you have to remember that you got chlorine with lone pairs. And it's not that I'm just some chem genius at all. Not at all. Just seeing this mech over and over again, and eventually you learn it. So one way to learn it really well is to write it out over and over and over until you get it, until you remember it. It doesn't take the brain of like physicists in order to do it. Anyway, so the lone pairs go to the AlCl3, and you form this complex. This is a lot like the bromination, which is, anyway, you've got these lone pairs, 1, 2, 3, 4, 5, 6. So this is positively charged because chlorine is happy with 7 electrons around it. But when it's only got 6, 1, 2, 3, 4, 5, 6, it's missing 1 electron, therefore it's positive. Al minus. Similar to how I told you the Fe is minus in the bromination, the Al is minus in this friedal crafts thing because that's just the way it goes. Anyway, now this is where it's different from the bromination, because in the bromination, the pi bond attacks the Br, and then this thing falls off. However, with this one, this thing just falls right off. It just falls off on its own because it's so nice. Anyway, you get this Cl, Al, Cl3, and then what's left? Simple as that. You have 1, 2 carbons, 1, 2, 1, 2. This bond here between number 2 carbon and that chlorine, it just breaks. So think about it like this. You've got your two pairs of electrons. This bond breaks and puts 2 more lone pairs on. So that now this thing's doing great. Cl, AlCl3 is also the same thing as AlCl4, obviously, because 3 Cl's, 1 Cl, that's 4 total. It's the same thing. However, I like to draw it like that. Now, going back to this beautiful one. We got 1, 2, 1, 2. This thing, the bond broke. That means some stuff left. So you've got a positive charge there. Now, think about it. We've got 2 carbons there. Don't invent carbons. Don't make them up. Just look at what you got. Now it's time for the pi attack. So I'm actually going to draw. Actually, no, we'll just leave it. Now pi attack. So this has got a positive charge. Electrophile. Bam. This pi bond's attacking that carbon there. Next step. So now this is where students get confused. How does this thing add? Right? Well, I want to add it right here. So that means there's a positive right there. This is how I do it. So now, watch this. This is going to there. So now this carbon is actually that 2 carbon. So just bear with me here. 2. And then this thing has connection to 1. 1. So if you want to think about it like this, that's totally cool. Bond from here to there. There's our 2 right there. That's what it is right there. Because it's making a line and connecting to it. And then there's our 1. So 1 carbon, 2 carbon. There's our carbons. Think about it. We've got 6 here. We've got 2 here. We've got 6 here and 2 here. So we didn't add any. We didn't subtract any. We just did what we were supposed to do. Now that is crucial. This is where you do the dancing. When you added this thing, you have to come back here and remember that you've got an H right there. All right? Because you had a hydrogen there already. And then you added this thing on. The H is still there. Now this positive charge is, you got a positive there because you broke a bond and now it's electron deficient. Now it's time to deprotonate. So you use the bond between the Cl and the Al. Grab the hydrogen, that bond right there forms. And now you got your product. But you're not done. Why? Is there water involved here? No, that's the acylation. What are we missing? We're missing HCl and AlCl3. Those, because when the Cl grabbed an H, forms HCl. These are just kind of like minute details, but you got to remember them if you want that A, or that A plus. Who knows? And then you regenerate your catalyst, AlCl3. It's good. It's good to add those. Add them. Why not? Anyway, you got your main product. And that's all there is to it. That's the alkylation. Lots of fun. Practice it, get used to it. This was a really easy example. Okay, you should be able to, here, let me show you a little trick. Say for example, we're given this problem. You're doing this in the reaction section. And you're like, okay, I don't have time to write out this massive mech because you don't have time for that in the reaction section. You have to think about this. Unfortunately, you guys need to know the mechs and for the ones you need to know, and also you just need to straight up know the reactions. So a quick way to do this is just have that pop off. This is not like the correct mech. This is just a way to do it on the reaction section and do it fast. And realize we have 1, 2, 3, 4 carbons. So that chlorine throws off, bam. Now we have this. So just do that. This is how I do it. I just forget about this in the meantime. Again, this is not how the mech works. This is quickness. All right, so you got your positive charge, and now you have to remember it rearranges. So just kind of think about that. You got your secondary. It's not going to do anything after that. Got your pi attack. And you don't even need to show res here. You just kind of, there it is. Simple as that. That's how you get your product fast. Anyway, you can maybe have your own ways that you do it, but that's how I do it. Find out which works best for you, and I'll see you in the next one.